All right, we're going to look at polynomial division, and you're going to see this is used to find factors with the remainder theorem and our factor theorem. So if I want to divide whether x plus 1 is a factor, I'm going to let you do the x minus 3 for practice, is we use long division. Sorry for my ugly looking plus right there. But long division is, it's kind of like real long division, right? You have to keep up with things. So I'm looking at this x going in here would go 2 times. So x squared times x is x cubed. Then I multiply the x squared plus 1. That's where this x squared comes from. And you're subtracting this line. And you bring this down. And I can see x will go into x squared x time. Okay. And so then x times 1 is this x. Again, subtracting this line. And so this would be negative 6x. Bring the negative 6 down. I can see negative 6 times x gives me my negative 6x. And negative 6 times 1, negative 6. When you subtract this, these become positive. And everything cancels out. And what this means is that x plus 1, since I have a remainder of 0, you'll see given the remainder theorem, since this is a remainder of 0, x plus 1 is a factor of this polynomial. Like I mentioned, I welcome you to try the x minus 3, and I don't think you will get a remainder of 0. And so when we divide these polynomials, we're looking at our quotient, okay, which we just found, and then times whatever our divisor. Now, if this remainder, once again, is a 0, then we know we actually have a factor of that polynomial. Sometimes it's a little easier, and I think students even kind of like synthetic division because you get rid of all the variables. And the only thing you have to be careful of in synthetic division, notice here by dividing x minus c, you might wonder, why is that negative? Because we're doing x minus a negative 3 to make it positive. And so as you can see, you simply start with the highest power and you write the coefficients. But notice there's no x, and that's why we had to put a 0 here, and then the negative 5. In this case, the order, you bring this first value down, and now you just multiply. Negative 3 times 2 gives me negative 6. 7 minus 6 is 1. Negative 3 times 1, negative 3. I subtract that. Negative 3 times negative 3, 9. And I subtract that. And so the quotient, now I can write this as, notice we started with a power of 3, so it's going to be 1 power less, as 2x squared plus x minus 3. And this is the actual remainder. Now, if I do another example of synthetic division, and I see that I get a remainder of 0 in this case, and this is to determine whether 5 is a 0. I can see with my synthetic division it is. And that's where we come in with our definition for a polynomial. If we divide and we get this remainder of 0, then x minus c, in that last case was a 5, is a factor of our polynomial.